Hi guys, I'm Ankit. In this video, we shall see another problem on LeetCode. Maximum number of k sum pairs. So you're given integer array and an integer k. So in one operation, you can pick two numbers from the array such that their sum should be equal to the k. And we have to remove them from the array. So return the maximum number of operations that you can perform on the array. So that means we are given an example 1, 2, 3, 4. So if k is equal to 5 is given, if we take 1, is there any member like 5 minus 1, 4 is present in the array? Yes, we could find that. So these two will be equal to 1 plus 4 will be equal to 5. Hence, one operation you have did. So operation if you take the count, that is 1 now. From 0 it has become 1 because 1 and 4 will sum up to 5. So what has to be done? It has to be removed. If we are removing this means it will remain just 2 comma 3. We will not be actually removing that from the array. It's not possible. But just imagine the case here. We are removing that 1 comma 4 from the array. That means you cannot use it for further summation of the pairs. And then check. Now you have to check whether 5 minus 2 that is equal to 3. So if 3 is present in array, yes. So 2 plus 3 will be equal to 5 only. So that means other operation can be done. Two operations can be done. Number of operation that you can perform on the array. I mean, how many number of pairs you found in the array such that their sum is equal to k. Those are the number of operations which we need to find in the array and return the answer. So once you found 2 plus 3 equal to 5, that will be an empty array. Got it? So this is the question given. So what is the approach to solve the problem? So better solution is you can use brute force where you compare each element, but that will not look into that approach now. So as I said here, when I had explaining the problem, as I said, see, you start with 1 and you look for the element. When you subtract 5 from this element, how much it give you? 4. You look for 4 in the array. If it is present, yes, you can add the sum to 2 and that will be counted as one operation. Similarly, you remove those and when you go to 2 also, 5 minus 2, that is 3. You look for the element 3 in the array. If it is present, then summation will be 2 plus 3 equal to 5. So same thing, but we'll implement using the hash map here. In C++ we say unordered or ordered map. We can use unordered map, anything. So first we will have the elements, okay? 1, 2, 3, 4. So let's see how do we solve the problem using this hash map, this mapping function. So what we start with the first element, of course. As I said here, we have to look for the element that is present. Like 5 minus 1, 4 is present in the array or not. But here initially hash map is empty. It's an empty map. Nothing is present. So you start with 1. So actually 5 minus 1, that is k. Let's say a variable called complement. Okay. What is the complement of this number? That is nothing but k minus the given number. How much is it? 5 minus 1. That is 4. We have to check whether this 4, this key 4 is present in the hash map or not. No, it is not present in hash map. Initially the hash map is empty. Though we have it in array, but we are using a hash map. This array as I use because just for the explanation. But actually we are implementing using hash map. So initially hash map is empty. So you will not find 4 in the hash map. So if you do not find 4 in the hash map, you just insert 1 into the hash map with occurrence how many times? Once. So this is the hash map. So this is the key occurring once in the array as value as 1. So next move to next element 2. Again check whether 2 is present in hash map or not. Okay, not 2. Complement of the 2, that is 5 minus 2, that is equal to 3. So we have to check whether 3 is present in hash map. If 3 is present in hash map, then 2 plus 3 will be 5. But is it present? No, only 1 is present as a key in the hash map. So we are not having 2. So insert 2 with the value as 1 because 2 is also occurring once in the array. Next you move to 3. So once you move to 3, take the complement. What is 5 minus 3? That is 2. Is it present in the hash map? Yes, it is present. But one major thing which we need to look here is we have to check whether this value is greater than 0. Only then you can assume that yes, there is an occurrence of 2 in the array. If in case, let's say after this 3 we have one more 3, okay? let's say uh, you can understand that now value is greater than 0. So first we need to check whether 2 is present in hash map. If it is present in hash map, we have to check whether the value is also greater than 0. Only then we can assume that yes, element 2 is available. So 3 plus 2 will be 5. So in this case we'll have a variable called count, which was initially 0, it has become 1 because 2 plus 3, this added up to 5. Okay, fine. So next, okay, once we are done this count equal to 1, now what has to be done? We have to decrement this value to 0 again. Decrement the value of 2 to 0 again. Why? Because this 2 has been already used in this 2 plus 3 equal to 5. So you cannot keep the value as 1 because that might be later used in the next part. So we should not allow that because you can use the element only once. You may see 3 here, you cannot use this 2 because this 2 has been consumed by this 3 already. So that's why you decrement the value of 2 by 1. And one more thing you have to notice, we are not inserting 3 into the array, hash map actually. We are just checking whether the complement of 3 is present. If it is present, okay, count will be incremented and the value of that particular complement you just decrement to 0. So we're not inserting 3 into the hash map. If you don't find the complement of 3 in the hash map, then you insert 3 into the hash map. As if we done in the case 1 and 2, because complement of 1 was 4 and complement of 2 was 3, which was not present in the hash map initially. So I inserted those elements into the hash map. But when you come to 3, complement of 3 is 2, which we have found in the hash map. Hence, that sum is equal to 5. Hence, what we do? We decrement the value of the 2 to 0 and also count will be incremented by 1. That is one operation. So next, move to the next element. Again, complement of 3 is nothing but 5 minus 3, that is 2 itself. Is it present in hash map? Yes, but the value is 0, not 1, right? Because why? This 2 has been used by this 3. So we cannot use this same 2 for next 3. So in this case, do we have a sum equalizing to 5? No. No, in this case, no. So you insert 3 comma 1 into the hash map. Why? We may not know, there might be some other 2 occurring next in the array, like let's say after 2 here. So this 2 and 2 can be used, right? So that is a reason. Okay, just put that into the hash map. Next, move to last element 4 again. Complement of 4 is nothing but 5 minus 4. So we need to check whether this 1 is present in hash map or not. Yes, it is present and the value is greater than 0 as well. So yes, because this 1 is not being used by any element. So this is also summing up to 5. Hence what we do? We are not inserting 4 because we have found the complement and that is the value is also greater than 0. So we just decrement the value of this complement to 0. I mean decrement the value of complement that will become 0. So yeah, this is the operation. Hence, okay, operations, this will be get incremented by 2 because as you found the complement, this one and the other one. So this is the logic behind the problem. So I'll write the code for C++ and also I'll explain the logic for the Java also, where we'll get to know. So as I said, what we have to do, at first we need to create a hash map. So let's create a hash map. So in C++ we tell it as unordered map of type int, right? Because key is the element in the array and value is nothing but the number of times occurring in the array. So let's name it as map. So once you found the hash map, we have to iterate over the element in the array. So each number in the array nums. So first what we need to check? We have to check whether the complement is present in hash map or not. So let's create this variable int complement. Okay. What is it? So what is it complement? That is the given k value minus this number. So if first element is 1, you check for 5 minus 1 whether the 4 is present in hash map or not. So this is the complement. Complement equal to k minus 1. Now check whether this complement is present in hash map or not. In the mapping or not, unordered map or not. How do you check whether it is present in hash map or not? So in C++ we use the logic called map dot find of complement. If it is not equal to map dot end and map dot okay, so and map of complement. Now you check for the value if it is greater than 0. So if these two conditions satisfy, so what does it mean? Map dot find of complement if it is not equal to map dot end. Map dot end is pointing to the position next after the last element. So it is not pointing to the position. If the finding of the complement, this key is not pointing to the position after the last element, that means this key is present in the hash map, right? So in this case, when you come to 3, complement of 3 is 2, 5 minus 3 is 2. So we will have 2 present in the hash map. But when you check for this 2, will you be having 3 in the hash map? The complement of this? No, because 1 and 2 only be stored, 1 will only be the stored in the array. So you check whether it is not pointing to the end of the hash map. If it is not pointing, yes, that particular key is present in the hash map. It's not just enough to check whether the key is present in hash map or not. We have to check whether the value is also greater than 0 in that. Only in that case, we can confirm that okay, this element can be used to add up a sum total of k. Because if you found this 3, you cannot use this 2 here because this 2 has been consumed by this 3 already. So that is the two conditions we have to check. We have to check first key is present. Once we have checked the key is present or not, next you have to check whether the value is greater than 0. If that is so, so count should be incremented. So let's define the variable count equal to 0. So after incrementing count, we have to decrement what? Map of complement. Because this complement value has been consumed by this number. That's why. Right? When you find for 3 the complement of 2, this 2 has been consumed by this 3. So you decrease the value of 2 by 1. So that is what we do. Map of complement minus minus. What if in case this case doesn't satisfy? If I say here 2 only, you will not find the complement. Or if you go to 3 also, you will find the complement as 2, but the value is not greater than 0 in this case for this 3. So in such case, what you have to just add that particular key into the hash map. So map of number plus plus. Why? Because it's initially 0, so increment the count by a value by 1. So at last we need to return the count. Yes. Okay, okay, fine. Yeah, and I'll explain the Java logic also. So in Java, we use map integer of integer data type. So create it as new hash map. Then count is initialized 0 and each element in the array, first you find the complement and you check whether this key is present in the hash map or not. Here in Java we use the, in C++ we use the logic of this dot find of complement whether it's not pointing to the end of the hash map. But in Java what do we use? Map dot contains key of complement. We check whether this key is present in the hash map or not. If it is present, then you check whether the value, this dot get is used for fetching the value of the particular key. So this value is greater than 0, then increment the count and also decrement the value of that particular complement value. In C++ it was just like map of complement minus minus, but here we have to put the complement with the value decremented by 1. if if it is, if this condition does not satisfy, that means it's a new element, so you just add it. Either if already present, just increment the count by 1. If this particular key is not present, then initialize it with num comma 0 and then increment by 1. So both are same. So at last you return the count. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.